This is about Le Chatelet principles. It means what? I have an equilibrium. Both sides, the reactants and the products, they're exchanging positions. So as soon as I produce those products, they decompose, producing back my reactants. As soon as the reactants are produced, they react together, produce what? The product. So in this type of reaction, I have both present, reactants and the product, present at the same time. None of them is disappearing. Both of them are there. So today, we'll have a cobalt nitrate, it's pink. We'll add HCl to it. The pink color, because it has, correct, it has nitrate as a complex with the cobalt, will appear pink. This pink color, when I add HCl to it, the concentrated HCl to it, that's very dangerous here. Concentrated HCl acid is about 11%. So the pink color will turn what? To blue. Here it is. Second, let's take the third one here. Okay, I took this is cobalt nitrate. I will add enough of HCl to produce a blue complex of the cobalt, which is tetrachloro cobalt complex, blue. So when you add HCl to it, you will add, this is very concentrated, we have to be careful with this. 11 molar, very concentrated acid, you have to be careful. So I will add it a little bit, and then more. Wow, see how nice the blue color is? Can you see it? Now, I want to see what is, I put one side of the reaction, cobalt plus HCl, that was pink. Then when I added, cobalt by itself, H2O is pink. When I added HCl, turns out to the other side, the product side is what? Is blue. I want to return my pink color back. So now we'll make some voodoo stuff. I don't have a chicken or blood or whatever. Let's do. That's the blood of the chicken, correct? So now you follow me here, we'll add some tap water to it, see what will happen. I need my blue, I don't like that. I need my pink. So let's see here. Wow, it's pink. Somebody said, no, I don't need the pink. Let's back to the blue. Let's do the blue back. We'll add HCl to it, let's see what will happen to the pink. Let's go back to the hood and add to this HCl. So I add to this HCl, enough HCl to it. Okay, can you see it? Now somebody said, I don't like the blue, I want back to the pink, can I? Yes. Chicken bones and chicken blood. Let's go to, add some. Here it is. Can you see it? And it goes on and on and on. So what's happened to this? So let's have a marker and then put, okay, I'll put this one here in front. Let's have a marker here. Somebody has a marker? Just hold on, I'm looking for a marker. Oh, let's do it here, a piece of paper. How about that? Do a piece of paper here. Okay, let's put it in the board. We don't have markers, but we have a board here. Let me just put it in the board here. Just hold on. So, somebody has a piece of paper? Somebody has a piece of paper? Let me show you what's happened there in this type of reaction. So, we started with cobalt nitrate. We added what? HCl to it. It turns from pink to what? To blue. Then we established a cobalt. Thank you very much. Thank you. We started here with, look at this. We started with cobalt nitrate, correct? And this is pink. We added to it HCl. Then out of this one here, all of those are aqueous, correct? Aqueous, and this is aqueous. So then we added the cobalt has a 4, 2 minus. This is blue, plus 4H plus. Don't worry about the other ones. So those are inside the solution, aqueous, aqueous. But if you look at this, this is the blue, and double arrow, that's an equilibrium, correct? So now we took the blue here. This is the first reaction. The second reaction, we have a blue. Then we took the blue, correct? We add to it 6 H2O, and this is correct. This is 2 plus. It's 4Cl minus, and this is blue. This is pink, correct? Now we took the blue, added H2O to it. This is a pink. Now if I take this pink here, and add to it HCl, I get what? Blue. This is pink. This is pink. The other one is blue plus 4H plus. So you can see now, out of this reaction here, I can what? I can shift the chemical equilibrium to the product side or to the reactant side, depending on what the stress I put. So if I put here too much of H2O, the H2O is already present in the reactant side. Too much of H2O will push it to what? Towards the pink, correct? If I add too much of HCl will push it toward what? The blue. So more of this, more HCl will be to the right, correct? And more H2O will be to pink and to the blue. So, and this principle called Le Chatelet principle, if I put stress on one side of the chemical reaction, the chemical equilibrium reaction has to readjust itself, an equilibrium. Readjust itself by releasing the stress out of its way to go to the side with the least stress, correct? That's what it says. Give you an example here. I have, I'll take this one here. A plus B give you C plus D. So here is pink, here is blue, the reactants and the product. So if I add too much, add B, so where will be the shift? B will add itself to what? B will add itself to what? Add itself to what? To the left or the right? Where is B to begin with? To the left side. Why? To the left side. Already present, correct? Already present in the left side, correct? So what will happen? If I have here a balance, visualize as a balance here, two arms of the balance here, look at this, correct? That's a 0. This is right arm, and this is left arm, and this is A, this is B, this is C, this is D. So I added what? add B, B will add itself where? Another B, correct? So this arm will be what? Heavy, correct? This one will be what? Light. Everybody following? So, if I add more B to the reaction, look at this. B added to the side where the B already present. So this arm of the left side will be what? Will be heavier, correct? Everybody's following? Will be very heavy. So the arm, we say the left arm, which is the reactance arm, correct? Reactance is more stressed, correct? In order to get out of this stress, some of the stress had to where? The shift will be which way? To the least stress, which is to the right arm, correct? Some of the weight has to go to the right arm to balance the two arms to be equal in weight, correct? So the shift will be to the right side, correct? To the product side. And then everything will be turned what? Blue. To the blue side. Make sense? Any question you have? No question? That will conclude the summary of the Le Chatelier principle. Thank you. Thank you very much. Okay. So